In this exercise, we will assess the effect of a change in split between one secondary circuit and the other secondary circuit. Oftentimes the um, ball mills are of identical size, and when the design is done, the cyclones are operating in exactly the same way. But we need to see what happens if the split changes during operation. So if I click on exercise 7, I can see that the simulation asks what will happen if 40% of the feed is directed to circuit 1. So I have to click on the splitter and say instead of 50% to the left, I'm sending 40% to the left. After I've done my simulation, I can see that I have a very good situation here where the sag mill and the crusher is behaving well, and I have blue icons everywhere, which means if I am to make this split, in this specific case the scenarios would work out. If I check the ball mill, I can see that my real power is very close to but below the motor power. And in the cyclones, I have reasonable percentage solids and a reasonable recirculating load. So here the recirculating load was 349. In the second circuit, it's 329. So by doing this split, the recirculating load has increased over here. If I check my final product, I have 0.143 over there, and here I have 0.14124. So you can see by doing the changes, we will have different final grind sizes. If I try another one where I say I am actually sending 30% to one side and I do a simulation, I will see that now I will have problems in this cyclone. So what is the problem? The problem is that I have a high recirculating load. So in the advice column, it says that if you have a high recirculating load, you have different options that you can follow. You can reduce the spigot size or the apex, or you can increase the vortex finder diameter. So in this case, you would be able to go into your cyclone and then change the operating variables in order to fix the performance of this circuit. So in the next demo exercise, we will change the performance of the cyclone, the settings of the cyclone, in order to remove any errors in the secondary circuit.